my screen now? Can you see my screen now? Everyone see the screen?
Yes, we can see.
Okay, all right, good. Okay, so the chapter 5 is basically about exponential and a logarithm, okay? But before we talk exponential and logarithm, the first section is called inverse relationship. The reason we talk inverse before them because the logarithm and exponential equation they actually exactly inverse each other. All right. So before we talk the logarithm and the exponential equation, we want to know what is inverse. All right. So the inverse of this relationship, look at this is 1, 2, 3, 4, 4 points in here. All right. So what is my inverse for this one? Inverse, basically, they just exchange X and Y. Okay, so the first one right here, so you can write down. All right, so the first one right here, I have a 3 negative A, right? And this inverse, all right? This inverse, switch X and Y. So switch X and Y, okay? When you switch X and Y here, Y become X. So Y was negative A. So negative A become X. 3 is X. So this is X. This is Y. Now this X become negative A. Y become 3. All right. And if I put this whole thing in the XY coordinates, trying to see how you look at that. All right. So I have an X 3, 1, 2, 3, right? And then negative 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. All right. So that will be right here. All right. 3, negative 8. So this point is 3 and negative 8. All right. And if I find the inverse, my X will be negative 8. So that will be 1, 2, 3, 4, 5, 6, 7, 8, negative 8 in here. All right. And Y will be 3. So that's 1, 2, 3. So somewhere right here. All right. So that is my P prime. Okay. So you call this is P prime. This is point P. All right. So point P here is 3 and negative 8. My P prime here will be negative 8 and 3. All right. But if I connect these 2 points together, if I connect these 2 points together, okay, I can connect these 2 points together. And then I drop Y equal to X in the middle, Y equal to X. All right. So this is Y equal to X. All right. 45 degrees, right? This will be kind of perpendicular to this one, all right? And then this is perpendicular to this one. So PC, we're gonna call this is C. P prime C and PC will be exactly equal. These two will be exactly equal. So what does that mean in here? It means the original point and the inverse point, they are symmetry along with Y equal to X. Okay, so you have this kind of identity in here. Any questions? So you just switch the X and Y, right? This Y, this X become Y, all right? So we have a Y. This one is 3 in here. Okay, so this one is negative 8 and 3, all right? 3 in X become Y. This Y become X. So that is called the inverse in here, okay? And if you have a 6 and negative 6 similar, the inverse will switch the X and Y. So what is the inverse for the second point? Will be negative 6 and what? 6. Okay. And negative 5 or negative 3 inverse will be negative 3 and negative 5. So that should be pretty straightforward for the point by point, right? And this inverse will be negative 5 and 5. All right, so just switch the X and Y. So pretty straightforward, right? A lot of time we are not just finding the, the point by point inverse. A lot of time we want to find the function, inverse function, okay? So in order for a function to be to have an inverse, we will need to have a one-to-one function. All right. So what does one-to-one mean? Using the horizontal line test to determine whether the function is a one-to-one or not. Okay, so one-to-one function, that means 1x only have a 1y. 1y also only have a 1x. Okay, so if 1x only have a 1y, this is called pass the vertical line test. If you also have a 1y corresponding to only 1x, we call this one pass the horizontal line test. All right, so use the horizontal line test to determine whether the function is a one-to-one. Horizontal line itself is not enough. Okay, it's not enough to say the function is a one-to-one. It also have to pass the vertical line test at the same time. Okay, so look at this one right here. This is a graph, right? If I drop the horizontal line, this is only past 1 point. If I drop a vertical line anywhere, it's also only past 1 point. So this straight line will be a one-to-one function. Okay. Why the horizontal is not enough? Because it has to be a function first. Okay. In order to be a one-to-one function, it had to pass the vertical line test. So pass the vertical line test qualify as a function. All right. And on the top of the function, we also have to pass a horizontal line test. So just only one line is not enough to identify one-to-one. Okay, number 3, is this a one-to-one? The answer will be yes, right? This one is a straight line. If you do not know this is a straight line, we can put it in a calculator. All right, I just start a calculator. We can graph this one in the calculator. Will be easier. All right, so we have 3x minus 2. All right, so 3x minus 2. All right, and then we can graph this one right here, right? And then let me zoom to standard. All right, so this have a y-intercept here as 0 and 2. This one, if you drop a vertical line anywhere, you only pass this line 1 point, right? And then drop the horizontal line, it's also only pass 1 point. So yes, this is a one-to-one function. Okay, so one-to-one function, is this a function? Yes, this is a one-to-one function, right? And one of formula for this inverse function. Okay, so the question here is how do we find this whole graph, the inverse function? We learned how to find point by point earlier, right? We just switch the x and y. So this one, if you want to find the inverse, step 1, okay, so that's step 1, change, or rewrite the f of x into y. Okay, so we have a y equal to 3x minus 2, so that's step 1. All right, step 2, you need to switch or exchange, whatever you want to call it. All right, exchange x and y. All right, exchange x and y. So what does that mean in here? That means y gonna become x. Okay, so y here, y become x. X become y. The rest is the same. All right, so that's called exchange x and y. Look at it, this y become x, right? And x become y in here. All right, so that is step 2. Step 3, I usually call this is a new y. All right, so we're gonna need to solve for new y. All right, so we're gonna need to isolate y by itself. So we're gonna add a 2 on both sides, right? So x plus 2 will be equal to 3y. And then you divide it by 3 on both sides. So we're gonna have a y equal to x plus 2 over 3. Okay, and then rewrite the y into inverse notation. So f inverse of x, we are equal to x plus 2 over 3. And this is the formula for the inverse. Okay, if I graph this inverse in a calculator, let's see what happens. We have a y equal to x plus 2 over 3. All right, that's my inverse. Okay, and then we graph them. So the right one is the inverse, right? And if I graph y equal to x in the middle, all right, look at this one right here. Y equal to x is exactly in the middle in here. All right, if I go to look at my table, you can see, oh, look at this, x and y is, okay, so that is x, y1, y2. Well, this is the entire graph, right? So if you look at this graph and then I have y equal to this one, they are exactly in the middle, okay? Exactly in the middle in here. And you can see why everyone passing this point. Well, you can see this point, x is 1, y is also equal to 1, right? So if we plug this whole thing in, when x equal to 1, y is also equal to 1. And you plug the original one here, when x equal to 1, 3 minus 2 is also 1. That's why everyone passing this point, 1 and 1, right? If you switch the x and y, x is 1, y is 1, inverse is still 1 and 1. All right. So that is this kind of formula, which we need to know how to find the inverse, right? Step one, you change the f of x, write the f of x into y. And then step two, you switch the x and y, and then you solve for this new y, okay? And then we write down this, inverse notation for the function. So that's it, that's the inverse. All right, so that is your first section, pretty much the first section for the chapter, okay? So that's the 5.1 in here. The given graph is a one-to-one function. Can you sketch the inverse function? Okay, so let's see if we can this graph in here. Right, let's see where's the graph. Okay, so here is the graph. Okay, so how do I this one is find the inverse by the picture, right? By this graph. We don't have a function, but we can this is all straight line. So if you just find 1, 2, 3, 4, find this 4-point inverse and then you connect them together, and that would be the inverse. Okay, so there's no equation here that you can find. This one, -7, -7. Look at that. X and Y are the same. So if they switch the X and Y, they're still the same. So this point will be also the inverse point, right? And if you have a 0, -5, the inverse will be -5 and 0. So it should be right here. All right, this is on the y-axis. Inverse will be on the x-axis in here. -5 and 0, right? And this point is 2 and 1. So the inverse will be 1 and 2. 1 and 2. So 1 in here, 2 in here will be right here. All right. 5 and 3, inverse will be 3 and 5. So 3 and 5 will should be somewhere right here. All right. So you can go to check the graph one by one, trying to see which one fit. Okay. I didn't, for the printout, I always miss one graph in here. All right. So, but we can see like which one is correct. Let's see if the first one is correct or not. And then you do this for everyone, right? You do have everyone has a -7, -7. So this point looks like everyone has the right one, okay? And we're gonna check the second point. Second point, this should be 5 and 0. All right, so this one don't have a 5 and 0, so this one A is gone, right? Or -5 and 0. All right, so should have a negative. So this one looks like a -5 and 0. This one also looks like I have a -5 and 0. Okay, missing a graph D. And then you look at this point in here. This is 1, 2 and 1. So it should be 1 and 2. All right, if you want, you can make it really big to see a little bit clearly. All right, A is already gone, right? Because we checked that wasn't right. All right, so this one should be They both have a -5 and 0. All right. And this point should be 1 and 2. So 1 and 2. Now this one still 2 and 1. You can see this is smaller, but you can enlarge that. All right. And 1 and 2. So this looks like I have a 1 and 2 in here. So B is gone. All right. B is gone. So this one still right. Third point still right. Okay. And then look at the last point here. Last point should be 3 and 5. Okay. 3 and 5. All right, so this last point don't have a 3 and 5. You can see this one, x should be 3, y should be 5. Okay. This 5 and 3, the inverse should be 3 and 5. So looks like this is incorrect as well. Okay. There's a graph D here that I couldn't print it out. All right, so that there must be D, somewhere that is correct one. Okay. But that's how you check. All right. So that's how you do this kind of question. You just check every point in here. All right. Any questions? Okay, so the second section here is we need to be able to graph the exponential equation, okay? Using the transformation to graph this one right here. Okay, so the graph for this one, we know y equal to 2 to the x. 2 is called a base, okay? This is called an exponential equation, exponential. All right. And 2 is the base. X is called an exponent. Okay. And then if you go to graph this one right here, this will be y equal to 2 to the x, right? You're going to have a y-intercept. Do not have an x-intercept, but you do have a y-intercept when x is 0. All right. When x is 0, y will be 2 to the 0. 2 to the 0 is 1. So you always have this y-intercept if you have this y equal to 2 to the x, okay? And we can put it in the calculator, graph them. You can use the calculator, graph the exponential equation. All right, so 2 to the x power. Okay, this is the, oh, all right, so this is the exponential equation, right? And if you want to look at how much is the x, how much is the y, you can come to the table. All right, so you can see even x is negative, y is still positive. Okay, so the exponential equation y is always greater than 0 in this case. All right, without a transformation. If I have a base is less than 1, like I say 1/2 to the x power. Okay, this one is base is less than 1. When the base is less than 1, the graph will be a decreasing one. So look at that, the graph will be a decreasing. All right, this exponential is a decreasing one. Okay, so those two are the two types of the graph you will need to be able to identify. All right, base greater than 1, base less than 1. Okay, so how does this one look like? The number 5, actually this base is less than 1. You will just wonder why this one base is less than 1. Look at that. We have a y or f of x equal to 5 to the negative x power minus 1. So let's just look at the y equal to 5 to the negative x. Let's graph this one first. Okay. This one you can write down as 5 to the negative 1 power x. So 5 to the negative 1 power is 1 over 5, basically. All right, 5 to the negative 1 power is 1 over 5. All right, or 0.2. So this one, the base is 1 over 5, which is less than 1. All right. If you don't really know, you can use the calculator to see how much it is 5 to the negative 1 power. 5 to the negative 1 power, right? If you go to calculate 5 to the negative 1 power, it gives you 0.2. All right, it's not a negative number, it's 0.2. And if you go to math and then change this whole thing into fraction, that's 1 over 5. All right, 1 over 5. So 5 to the negative 1 power, if you move 5 to the denominator, become positive. So 5 to the negative 1 power is 1 over 5. All right. So this one is 1 over 5. 1 over 5 to the x power. Okay, I graph this one. So this one is a decreasing function. If I graph 5 to the negative 1, 5 to the negative x power, it's giving you the same graph. All right, these two are equivalent. Okay, so look at that. I graph this one, I have a blue one, now I have a red one, exactly overlap the blue one, right? So that means these two graphs are exactly the same. Okay, all right, so now if we have this one, and this whole thing, okay, trying to look at the original question. This is my original question in here. Okay, all right. So using the transformation to graph this one right here, right? So we know the negative one, this is 5 to the negative x is a decreasing function. And this minus 1 is not on the exponent, it's on the y. So this is moving down for 1 unit. All right. This whole graph minus 1. So that means the original graph will move down for 1 unit. Okay, look at this one right here. So original one was the same, right? But now I have this red one moved down 1 unit in here. Okay, moving down for 1 unit. So and then you go to choose the correct answer. Apparently this one is not correct, right? This one is moving up for 1 unit. So A and C both are incorrect in this case. All right. And then you can go to see which one is the correct one. This one is incorrect. So looks like the correct one should be the D. Okay, but I don't have a complete graph in here. All right, but that's how you identify. Okay, even without a graph, you should be able to describe how this look like in here. Okay, now we're gonna find a logarithm. Okay, so 5.2 is about a exponential equation, and then 5.3, we're going to have a logarithm. Okay, so what's a logarithm? Let's see if I graph y equal to 2 to the x, right? And then if I switch it, the inverse for this one will be x equal to 2 to the y. All right. Because I switch the x and y, look at it in here. All right, so how do I graph this one? I'm going to just give you a little bit quick demonstration in here, right? So x can be 0, can be 1, can be 2, negative 1, negative 2. So 2 to the 0 power is 1, right? And then 2 to the 1 power will be 1, 2 to the 2 power will be 4, 2 to the negative 1 power will be 1 half. 2 to the negative 2 power will be 1 over 2 square, or 1 over 4. Okay? If I switch the x and y, let's see. Okay, let's graph this one first. All right, so I have an x. Oh, not quite straight. All right, I just graph by hand, so bear with me in here. All right, 0, and then we're gonna have a 1, 2, 3, 4, 5. Okay, something like that. All right. Okay, so we're gonna graph this one right here. This is exponential, right? When x is 0, y equal to 1. Okay, when x equal to 2, y will be 4. So right here. When x equal to negative 1, this will be 1 half. Okay, so 1 half, somewhere right here. When x equal to negative 2, this will be even smaller. All right, so when I graph this exponential equation will be something like that. All right, so that's y equal to 2 to the x, right? If I switch the x and y, that's what happened. Switch x and y, so this one will become x. All right, so switch. So we're gonna switch the x and y. So that means when I have a x equal to 1, so this x equal to 1, y will be 0. This y is 2, y become x, right? And then this become x, this become y. Uh, Something like that. If you switch the x and y, that's exactly what happened. All right. So we're gonna have a 1 and 0 right here. Okay. And then we're gonna have a 2, and then this will be 1 right here. All right. And then we're gonna have a 4, this will be 2, 4, this will be 2, will be somewhere right here. Okay. And then we're gonna have a 1/2, this will be -1, 1/2, this -1 will be right here. Right. And then we have a 1/4. This will be -2, so that'll be right here. So this will look something like that. All right, so that is x equal to 2 to the y. Okay, and if I graph y equal to x, this will be exactly in the middle. All right, so that is the inverse equation. And if I want to write down this one equal to y equal to, that's why we put a log in here. Okay, so x equal to 2 to the y. If I want to solve for y, y will be equal to log base of the 2x. So that's why it's a logarithm. So how do I change the logarithm? This 2 is the base. 2 is also the base in the logarithm. So base stay the same, right? And this exponent become the logarithm, become the y here. All right. So if I graph this one in a calculator, look at that. If I graph this whole thing in a calculator, I have a 2 to the x, 2 to the x power, right? And then make a graph. So that is an increasing one. And if I want to graph log, where do you find a log? I can go to my math and find a log base. All right. So this one I can graph the base log is 2. And then the x here, log 2 of x. Okay. And I graph this one right here. You can see that's exactly inverse each other, right? This is supposed to be coming down, but the calculator, sometimes don't graph all the way. All right, if I have this y equal to x, that exactly in the middle. All right, so this is exactly the exponential and the logarithm that exactly inverse each other that way. All right, so that is the one we learned earlier for the inverse function. Okay. All right, so I just giving you the actual review for this section, pretty much go through that section, right? This one, we will need to be able to find a logarithm for this one without using a calculator, okay? So there's a little bit property you will need to know in this case. Some of them you do need to use the calculator to find, all right? And this one you don't need to. So what is the property here? Log of 5, 125, right? If I do not know how much is this one, I'm gonna say this is equal to n. And then we're gonna solve for n here, right? And this one, you need to be able to convert into exponential equation, okay? So this one means 5 raised to the power of n equal to 1 over 125. And then we're gonna solve for n. All right, and this one I can write down as a 5 cubed. 125 is a 5 cubed, right? And this 5 cubed, if I put it into the numerator, it will be 5 to the -3 power. So look at that. If I have a 5n equal to 5 to the -3 power, that means n should be equal to -3 in order for these two to be equal. If you have a b to the x power equal to b to the y power, when they have a same base, exponent must be equal. Okay? Exponent must be equal in order for these two to be equal, since they have a same base. Okay? So this one I converted into same base, so the exponent should be equal in order for this to be equal. So that means this whole thing is equal to -3. All right. You can also put this one in a calculator. Yes, calculator, we are we are giving you the answer as well. Okay, so I'll show you how to get a calculator with the answer. But this one you should be able to solve without a calculator. Okay, but you can also use the calculator. Go to the log base. All right. If you don't have a log base, we will have a changing base formula later on. Okay. All right. And then you have a 1 over 125. Okay, so double check. This one, it is equal to -3. All right, so that's using the calculator in here. But I just using the algebra to solve. Okay, using the change the log into exponential equation. So this one, you will need to know how to use this one because not every time you're gonna have a number be able to put in a calculator. Okay, so you always need to know how to switch from the log into non-log, into the exponential, or from exponential to logarithm. All right. Number 7 here, we're gonna have a log 5 of 5 to the this is 6 root of 5. Okay, so what is this 6 root of 5? Well, we can just still put this whole thing equal to n first, right? And then we can convert. I usually say, how do you convert a log into exponential equation? You drop a little bit circle, start with the base. So base 5 raised to the power of n equal to 6 root of 5. All right. And this one we're going to write down into the exponent. So 5 is 1 over 6 power. This is power of 1, right? 1. Look at it. If you have a to the m do m power, this whole thing is equal to n over m. All right, n over m. Okay, so n here will be 1 over 6 because you have a same base here. Exponent should be equal. All right, and same thing, you can put in a calculator, but this one you should know how to do that without a calculator. All right, because we have this one right here, you need to be able to convert, right? Convert this whole thing into the exponential equation. Okay, so how do I convert this one into exponential equation? Well, we just said it earlier. Okay, log base p of b equal to -x. All right, drop a little bit circle is going to the counter crosswise, right? So start with the base, start with the base p. So p raised to the power of -x will equal to b. It's not p to the b power equal to x. No, this is incorrect. All right, so it's base p raised to the negative power of x equal to b. So coming to the right hand side, okay, and then back here. So that is the exponential equation for this one. Okay. Find a logarithm using the change base formula, right? As I mentioned earlier, not every calculator will have a different base of 5 or or 2. Some of the calculator you only have a outside one here. This will be the common log. Log is called a common log, right? So this is base 10. Ln is a natural log, which is base e. Okay, so some of the calculator only just have this one, don't have this math in here, don't have this changing base, this log base. Okay, if I have this log base, I will show you this formula. You're gonna come out to the same answer. All right, log 5 of 14 is come out with 1.6397, right? And if I change it into changing base, so this one you will have a changing base formula. Okay, log x of y, we can change it into some other third base. Okay, log b of y over b of x. All right, so I change it into a base b. This one is base x, right? And I change it into base b. But we usually don't want to change it into any other base. We like to change it into common base. All right, log, which is base 10. On the base 10, we don't have to write down 10, right? Or we have ln x over sorry, lny. This is going to the top. All right. So it's lny over lnx. Okay. So this is a changing base formula, which is in our book. You will need to know. If I change it into log, okay, so look at this one right here. If I change it into log 14 divided by log 5, this is giving you the same answer. These two are exactly the same. Look at it. Okay, so that's why you can using the changing into the common law, or you can change it into ln 14 divided by ln 5. Okay, this will also giving you the same answer. Look at it. All right, so that means you can change it into any other base as long as the numerator and denominator has the same base. They are all equal. Okay, so that is called changing base formula in here. All right, you can change it into any base. Any question about number 10? All right, let's look at number 11. Express this one into a single logarithm. All right, so this one we have to know the properties for the logarithm. Okay, so did we skip the number 10? Oh yeah, we skip one of them, number 10. All right, number 10 here is express the this one in terms of sum and difference of the logarithm. All right, so same thing, you will need to know the properties of the logarithm. Okay, so number 10, 11, so we have one called product rule. Log a of m plus log a of n, so the base have to be the same. This will be equal to log a of m times n, not log a of n plus n. All right, so you have a two log, change it into one log. You have to change the operator here. All right, and if you have a log a of m minus log a of n, it will equal to log a of m over n. So this is called a quotient rule. Okay, and then we also have a power rule in here. This is m to the p power. P can be moved all the way to the front, become a coefficient, log a of m. All right, so this three rule, which is very important for this section, and you will need to know the product rule. So this is multiply product rule. This is quotient rule. This is called a power rule. This is a power, right? And then you can take all the way to the front, become the coefficient. Okay, so using these three rules, you will be able to combine or expand the logarithm. Okay, so number 10, you want to expand. So this is log without a base. So that means log 10. It's a common base in here. All right. And this is square root of a to the 4b. I can write down this whole thing into a4b to the 1/2 power. Okay. And I can distribute this 1/2, or I can take this 1/2 all the way to the front. All right. And then I will still have this one is called a product rule, right? So just make sure when you expand this product 1/2, you need to multiply everyone. Okay. So this will be log a to the 4 plus log a log of b. All right. So this is a multiply. So you will need to have a product rule, right? So this is addition. Okay. Using this formula in here. All right, and then this one, A can be taken to the front, become the coefficient. All right, and then this will be log B. You can leave the 1/2 outside if you want. If you want to multiply that in, that's fine. When you multiply that in, you need to simplify. Okay, all right, so that can be the final answer. So you can have this one as a final answer, or you can have a 1/2 outside as a final answer as long as you have a parenthesis. All right. So that means we change it, we break down, expand this one into addition or subtraction, sums or difference in here. This one is just the sum, right? So that is this one. That's what I mean in here. Okay. All right. Number 11 here is you want to combine this one into one single log. Okay. So that means we need to use this property backward. All right. Left to right, right to left. Okay. So how do we do that? This is ln of minus 3 ln of this one. I'm going to write down this one into uh exponent. Okay. If you don't want to write down into exponent, that's okay too. Okay. So just keep it as it is for now. All right. And in order to use this product or quotient rule, look at that. This coefficient, all the coefficient product or quotient rule, all the coefficient here must be 1. Okay. So this one has a coefficient 3 here. I will need to move 3 back to the power. Okay. So this whole thing, I will need to move this 3 back to the power here in order to use the in order to use the the properties. All right. And then this one is a subtraction. Okay, we're going to simplify this a little bit in here, actually. All right. Because this cube and q loop, actually, this can be canceled out, right? So this will be just minus ln of x squared, basically. Q loop and Q can be canceled out. Okay. Or if you don't want to put this one back, look at it. You can also do this way. All right. You can have a through it, and then this will be ln of x squared, right? And then this will be 1 over 3. So 1 over 3, you can take it to the front. Okay. You can also do this way. All right. And then this 1 over 3 will cancel out. All right. And then you want to have a ln of x minus ln of x squared. So these two are the same. Look at it. Either way you do is to give you the same. And then this one will be the quotient rule, right? So quotient rule. So this will be x to the 6 divided by x squared. Same thing, quotient rule, x to the 6 divided by x squared. And of course, you simplify this one. So this will be just ln x to the 4, right? ln x to the 4. And if you want to simplify even more, you can take the 4 to the front, become the coefficient. So that will be just 4 ln x. All right. Or you can leave a ln x to the 4, leave this one as the final answer, still fine. Okay. All right. So that is using the property, you combine it into one single logarithm. Okay. So that is what I mean in this case. All right. Any questions about this one? Okay, number 12 is solving for the x. Okay, solve for the x here. You can see this one is an exponential equation, right? So I can solve for x by changing to the same base. Okay, 6 to the 2x, this is 216. I can divide it by 6, right? That will be 36 divided by 6. This will be equal to 6. So that's a 6 cube. All right. If you don't know, you can use the calculator. All right. So 216, let's see, divided by 6, right? And you got a 36. Okay. And then that is a 6 cube. So same base, exponent must be equal. So 2x must be equal to 3, or x is 3 over 2. And that's it. That's that. All right. So should be really straightforward for this one. Okay. You solve for x. This one is you solve this one right here. So the second way to solve the exponential equation, as you can tell, this one I cannot change 3 into 7 or 7 into 3, right? So what does that mean in here? That means if I have n equal to n, I can put on the log. Log m will also equal to log n. Okay? This one actually can back and forth. If you have a log m equal to log n, m and n should be equal. All right. So that's exactly what we're going to use in here. I'm going to put a log on both sides. Okay. put a log on both sides in here, and that will be still equal. And then this x can be taken to the front and become the coefficient. Okay, and now we can solve for x by divide both sides by log of 3. All right, and we can go to estimate this one right here. Look at that. We can set 1 to 3 decimal place. Okay, so we have this one log. It is. So we have a log of 7 divide log of 3. All right, and that is about 1.771. Okay, you want to round to 3 decimal points. So this is a regular rounding, right? My fourth digit is 2, so you round it down. So it's 1.771 in here. Okay, so x is about 1.771. And we can look at this one right here, 1.771, trying to see if this one is almost equal to 7, because we round it down. So this should be a little bit less than 7, but should be very close, right? So we're going to go to check our answer. 3 to the 1.771 power. Oh, how much is that? Well, that's 6.998, right? So we accurate to the thousands, right, in here. So we have a 6.99. If I using more decimal point, 1.77124,749. Okay, I'm gonna use all these decimal point. Look at this one right here. This will be 7.0000 something, right? So this will be very close to 7 in here. All right. So that is how we find this one right here. If we don't have a logarithm, it's very hard to estimate x value, right? Because if I using 3 to the 1 power, that's just 3. But if I using 3 squared, that's 9 already. So this x must be between 1 and 2, but we do not know how much. Okay, it'll be really hard to estimate to this many decimal point. So that's why you're using a logarithm in here. You can solve this one easily. Okay. Any questions? All right, so this one is actually is very similar. Okay, solve for this equation. Okay, if I have both sides has a x, same thing. Actually, very similar to this one. I will need to put a log on both sides, or you can put a ln on both sides. It's the same thing. This time, let's do the ln. Okay, you put a ln on both sides. All right, so it's very similar. X will be become the coefficient. This one, x plus 3 will become the coefficient because both this x plus 3 is the entire power. So this will be the coefficient, right? And then we get rid of parentheses, okay? Get rid of parentheses. And then we're going to move from minus x ln 7 on both sides. All right, so this will be x ln of 21 minus x ln of 7 equal to 3 ln of 3. All right, and then we pull the x up. Look at that. All right, and then we solve for x by divide both sides by the ln 21 minus ln 7, and that is called the exact solution. All right, this one is called the exact solution. If we want you round to 3 decimal point. Okay, so this one, it does ask you to round to 3 decimal point. So we're gonna go to use the calculator. All right, use the calculator to round. Okay, so 3 ln 3. Okay, make sure you use the parentheses. All right, so my denominator here is ln 21. ln of 21. All right, this one add a parenthesis, so I have to close them. Minus ln of, I think it's ln of 7, right? Got it, right? Yeah, ln of 7. All right, so tricky part is the add a parenthesis here. Make sure you close all of them. All right, so that is, okay, let's see what question is this one. Number 14. Okay, let's see if you got it right or not. Ln of x, ln 21, x plus n, ln 3. All right, so x times ln 7. Oh, my mistake here. Look at it. Why I'm making mistake. Okay, apologize for that. This one should be 3 ln of 7. Look at it. I put a ln of 3 in here. Okay, so that's why this should be 3 times ln 7. So that should be ln 7, right? So that's 3 ln 7. Okay, 3 ln 7. 3 ln 7. Okay, that is should be 7 in here. All right, so that's 3 ln of 7. Okay, divide by this ln of 21 minus ln of 7. All right, so now that will be the correct answer. 5 point round to 3 decimal point. My fourth digit is 7, so you need to round up, right? So 5.314. Okay, 5.314. All right, so that's how you estimate into 3 decimal point in here. Okay, I forgot this one. I just write down, I make a mistake in here, right? 3 times ln 7 should be 3 ln 7 in here. All right, so that is how you solve this type of equation with both side x, okay? That probably a little bit more complicated one than the other one. All right, so this one is called a logarithm equation because you already have a log. All right, and solve this one right here is I can combine this into one log. Okay, we can combine the using the property, right? So this will be log x times x plus 9 equal to 1. Okay, combine it into one log. Since my right-hand side is a number, so this is base 10. If you don't write anything for log, that means base 10, right? And I can convert this into exponential equation. Look at it. 10 raised to the power of 1 equal to x times x plus 9. So this is 10, this will be x squared plus 9x, right? And then we're going to solve this quadratic equation minus 10 on both sides, minus 10 on both sides, okay? And then we can factor this one into x plus 10, x minus 1, x minus 1, okay? Because negative 10, you can have a positive 10 times negative 1 or have a negative 10 times positive 1, right? But these two added together, you got positive 9. These added together, you got negative 9. We have a middle one is positive, so that's why you choose this one, okay? If you go to solve this one, x will be negative 10, x will be 1. All right, so we do have to check the solution. With all the log in here, x should be greater than 0. The second log, x plus 9, should be greater than 0. Okay, that is the domain for the log. And this one, x is negative 10, so you have to get rid of this one. So this one, you have to discard that one. All right, the only solution will be just x equal to 1. Okay, because we cannot keep this solution. It didn't fit into our domain here. This each log x should be greater than 0. This log of x plus 9 should be greater than 0. All right, so that's why you also have to check the solution for the logarithm. Okay, solve this one. Solve this log. So this one, that means we need to find a solution for the b, right? Looks like b is the only unknown in here. So this one, if you have a both sides have a log, as long as I combine it into one log, I can get rid of log. But this got two logs, so I will need to combine them using the quotient rule. All right, this is quotient rule. Okay, equal to log 4 of b, and then this log can be get rid of them because each side only have one log. All right, each side only have one log, so I can get rid of this log, and then this you cannot get rid of the log at the beginning because this have got two log. All right, so using the quotient rule combined into one log, and now you can have that. You can get rid of the log. All right, and then multiply both sides by b plus 7. Get rid of a fraction, right? Get rid of this fraction. All right, get rid of this fraction. So we're going to have a b plus 16 equal to b squared plus 7b, and then minus b minus 16 on both sides, minus b minus 16 on both sides. So this will be 0, right? And then that's b squared plus 6b minus 16. And this one, you can do the factoring, okay? So you can factor this one. Negative 16, you can factor into a and negative 2 because these add together equal to positive 6. So we're going to have a b plus a, b minus 2 equal to 0, right? And each factor will be 0. Okay, solve will be here, negative a and 2. All right. And the same thing, we have to go to check to see if we can keep these two answers or not, because this is a log. Okay, so let's see. We have a log b in here, or we got 3 log, right? So 3 log, that means I have to make sure all 3 are positive. So what does that mean in here? That means b plus 16 need to be greater than 0. B plus 7 also need to be greater than 0. That's their domain. Okay, so if you check 2, everyone is fine. But if you check b equal to negative 8, right? B plus 16 need to be greater than 0. Is this okay? Yeah, this is okay. B plus 7 also need to be greater than 0. But if you plug a negative 8 plus 7, this is not greater than 0. So that means this one is gone. Okay, the only thing answer here is b equal to 2. All right. Okay, 3 more questions, okay, for tonight. You want to solve x here, very similar. This one, you will need to change it into one log, all right? Solve log only have 2 ways. One way is combined into exponential equation, just the one we have, okay? Because this right-hand side doesn't have a log, so you cannot get rid of log. So this will be 2 to the 4 power equal to x plus 1 over x, okay? And 2 to the 4 power is 16, right? So you multiply both sides by x. So you're going to have a 16x, and then you minus x. So this will be 15x. So this x will be just 1 over 15. Very easy. All right. And 1 over 15 is, this will be greater than 0. X is also greater than 0. So this is a good solution. All right. So some of the question looks like a little bit easier than the other, okay? A little bit application for this one right here, okay? This one is supposed to, you have this much to invest. Interest rate is 6.2 per year, compound continuously, right? You want to find an exponential function that describes the amount of this amount after t years, and then estimate after 1 year, 2 years, 5 years, 10 years, okay? And what is the doubling times, all right? So looks like a lot of questions to answer, but basically calculation is similar, okay? This chapter, we do giving you a little bit of formula, or you can organize one page of formula if you want to by your own, okay? If not, we have at least 2 formula in the formula C. One is P equal to E to the RT. This one is for the continuous, okay? The other one is for compound, monthly, quarterly, all right? So N here is the number of the compound per year, okay? If you compound monthly in here, N will be 12. If you compound quarterly, N will be 4, right? If you compound annually, N will be 1, all right? So this one is a compound continuously, so you want to use this one, Okay, so A equal to P to the RT, that's compound continuously, right? And suppose you have this much to invest, so you have a $12,820, and the interest rate R here is 6.2%. You do need to convert it into decimal point. Okay, so 0.062T. All right, so that is your equation. Okay, and then that's your exponential equation after t years, right? After t years. Okay, and then you can put a t into 1. Okay, you can put a t equal to 1. So the b here is you put a t equal to 1, 2, 5, 10, whatever into calculation. Okay, I'm gonna just calculate 1, t equal to 5. So let's see how about t equal to 5. How do you calculate? All right, this will be times 5, right? And then we put this one in a calculator. Okay. All right, so we put this whole thing into calculator. So 1, 2, 1, how much? 1, 2, 8 to 0 times E. Okay, so you need to go to see where's E. Second ln is E. All right, E to the 0.062 times 5. Okay, and then you hit enter. So you have this much. We usually like to run to 2 decimal point or whatever the question asks, right? So you have a 17479. Right? On 1. Okay, so you have this much money already. Okay, so giving like if you have this much money deposit in a bank, right? You have a 17,000 something, and how much is interest you made after 5 years? You using the amount minus the principal, right? So 7.11 minus 12820. So you will have this much, whatever that is. So you have almost 5,000 interest in here. All right, you can minus 12820. All right, so you have a 4659. All right, 4659 on something, right? On one. All right, so you have a 4,000. If you have this money deposit in the bank after 5 years, you have a $4,659 as an interest. Okay, and you can put this one into 1 into 10 in here. All right, balance after this one in here. Okay, so you want to see how after 1 year. Yeah, this is balance after 1 year, after 2 years. This one you want to find what is the doubling time, right? So if you have this much money put in a bank, how much it will double? So this that means you need to find the time t. Okay, so you can see after 5 years it's not going to double, right? So we have a equal to p e to the rt. Double, that means this is gonna be 2 of the original one. All right, 2 times original one, so that's double. Okay, and then p and p cancel out, so we have a 2 equal to e to the rt. R is 0.062t, right? And in order to solve this one, I can put a ln on both sides. Look at that. Okay, and then this whole thing, this will be 0.062t. This whole thing exponent become the coefficient, and ln of the e is equal to 1. So we have a 0.062t equal to ln2. All right, so how much is the t? T will be ln2 divided by 0.062. So you can go to calculate ln of the 2, ln2 divided by 0.062. Okay. All right. So this is 11.2. All right. If you hold on to just 1 decimal point, with 11.2, about 11.2 years. All right. So if you put this much money in a bank with the interest rate is 6.2%, you will require almost 11 and a half or 11.2 years to double. Okay. So that is how you calculate this type of thing in here. Okay, so that is number 18. Okay. Number 19 here is a little bit application. A coin sold for 256 in 1975 and was sold again in 1994 for 73. Assume the gross value of the correct item was exponential. Okay, how do you find the value K of the exponential growth rate? Assuming the original value is this one. Original value is 256, right? So how do you do this type of equation in here? We find the exponential growth rate, right? So we have a 19. We have A equal to PE to the RT. All right. So this one we're using B. B0 is 256. So when T is 0, that's the year 1995, right? This we call a base year. Okay. And year 1990, how much is T? You're using 90 minus 75, so T will be 15. Okay, so B of the 15 is what? Is 473. Okay, so we can plug that in here. So B will be B sub 0 will be 256 e to the kt. Instead of using R, you want to using K. Okay, R here, it change into K. All right. And then we already have a when T is 0, right? So we're gonna plug a T equal to 15 in. Okay. So 15K. And then 15K B is 473. Okay, so we're gonna solve for K here. So how do we solve for K? We divide both sides by 256. This e to the 15K. All right, and then we put a ln on both sides. Look at that. We put a ln on both sides. So ln e to the 15K, we are equal to ln this one. All right, so this 15K is the power, become the coefficient, and ln of e. All right, ln of e is equal to 1. Okay, so this will be ln e equal to 1. All right, so K will be ln of 473 over 456 divided by 15. And you can put this whole thing into calculator to calculate. So that is about 0.041. Okay, so that is your growth rate in here. All right. So after calculating this growth rate, now we can write down B of the T. Okay, the second one here, B of the T will be 256 e to the k. K is 0.041 t. All right, so now we got this equation. Okay, and then we can go to estimate this whole thing. Estimate what's the value in 2009. All right, so you're gonna go to see 2009. How much is a t? Well, you need to compare to 75 t is 0, right? And then 2009, if you want, this would be 4, this would be what? 34. So t will be 34 years. Okay, 2009. So just plug a t equal to 34. Plug it in, and you can calculate this one. All right. So that is how you do this one in here. Number D here is what is the doubling time? Okay. The doubling time is very similar to the one we found earlier. Okay. So the doubling time, so that means I have a V of the T 256. Okay. And then I want to double. All right. So double, what does double mean? Double, that means, or you can use in the B's double. That means we're going to have a 2 times 256. That's double. Okay. And then these two cancel out. So you're going to have a 2 equal to e to the 0 point. This one, put a ln on both sides. Okay. So 0.6 lne. And then lne is 1, right? So double time, you're going to using ln2 divided by 0.041. And you can go to calculate this double time is about 16.9 years. Okay. So that's your doubling time in here. All right. And find the amount of the time which the value of the coin will be 1781. So how do you do this one right here? This one, that means I will need to find 1781 equal to 256 e to the 0.041 t. Okay, so you need to calculate this t. All right. So calculate this t. How do you calculate t? Well, you need to isolate this one, divide by 256 on both sides first, right? So you're going to have e to the 0.041 t equal to this one, okay? And put a ln on both sides, put a ln on both sides. And then this whole thing will become the coefficient 0.041 t. ln of e will be 1. All right, so you just use this whole thing divided by 0.041. So you estimate this one is about 47.3 years. Okay. We almost run out of time. That's why I didn't do the calculation. I just want to show you how to set up and then calculate. All right. This one is pretty similar. Okay. This town, this look very big, but actually you just plug it into the calculation. This one you don't actually have to do anything except plug the t into the calculation. All right. So after 2 day, 5 day, 8, 12, 16, the calculation is the same. Okay. So this is some kind of n infected t days after the disease had begun, given by this function, right? So when t is 0, okay, so let's calculate this one right here. When t is 0, how do you calculate this one? That would be n of 0, right? And that would be 3,500 divided by 1 plus 24.e. T to the 0 power, 0 times anything is still 0. All right. And e to the 0 power is equal to 1. It's not 0. Okay. So this whole thing, we are just using 1 plus 24.5 times 1 is still equal to itself, right? So you can just do this division, should be very easy. So that's about 137. All right. And then you can go to calculate t of 1 or maybe t of 8. All right. So how you calculate t of 8? All right. So 24.5 e to the negative 7 times 8. All right. You just need to use the big parenthesis in here when you do the type it into the calculator, into calculation. Okay. So let me just show you one calculation in here. How do you type it into the calculator, basically? All right, first, I need to have a big parenthesis, right, for the entire denominator, okay? And then I have a 1 plus 24.5 times e, second ln is e, all right? E to the negative 0.7 times 8, all right? And make sure I move down and then close my parenthesis. And hit enter. And that's it. That's your answer, okay? You want to run to the integer, so that'll be 3209. Oh, 3209. All right, so that is basically you just, so this one, don't look at the formula, it's very complicated, but actually it's very easy to calculate. Just plug the number directly into the calculation. Okay, the last question here is using this model, can you say whether all 3,500 people will ever be infected in spring? And then, what does that mean? Okay, so that means when T increase, okay, when T increase, what happened? That means if T increase very big, okay, so that means if T increase, all right, look at that. We can say like when original one when T is 0 is only 137, right? But when T equal to 8, we already got a 3,000 something, 3,209. So apparently when T increase, N of the T also increase. Okay. But how much it increase? This, I can rewrite this one a little bit. 1 plus 24.5 e to the negative power. If I want to write down the positive power, I will put it in the denominator. 0.70 will be the positive power. Okay, or I can write down this way. 24.5 divided by e to the 0.70. All right, so let's look at this one, the assumption here. When T increase, my denominator will increase, okay? Because E is 2.7 is greater than 1. So when the exponent increase, this whole thing increase. E to the 0.70 will increase, okay? And 24.5 over E to the 7.t. This denominator increase, my numerator is the same. So this whole thing will be decreased. All right, decrease to what? This will decrease to almost 0. It won't be 0, but when the T increase a lot, this is going to be decreased a lot. And this denominator will be just divided by 1. Okay, will be divided by 1. All right, divided by 1 will be just 3,500. Okay, so the number will approach. All right, when T increase a lot, yeah, this will getting close to 3,500 people get infected, but it will never reach that because this whole thing won't be go to 0. All right, this whole thing won't be go to 0 in here. Okay. All right, so the quiz, the test probably won't have a 20 question this many, but this is a review, so I'm giving you a little bit more actual in the review. I think on the test question, probably only 15 or 16 questions, okay? So some of the big calculation probably won't be in the test, but I just want to give you a complete review so you can prepare more, better than prepare less, okay? All right, any questions? I'm going to stop recording and then to see if you have any questions.